Ever feel like the sun is just this big, constant light bulb in the sky?
Mm-hmm.
I mean, you look up, it's there, it's bright, end of story, right?
Pretty much how most people think about it, yeah.
Well, prepare to have your cosmic perspective totally flipped. Welcome to the deep dive, where we take a stack of expert sources and pull out the nuggets you absolutely need to know.
And today, you've handed us quite the playbook. We're diving into the dynamic and interconnected world of heliophysics.
Heliophysics, right?
That's NASA and NSF's term for it. It's basically the science of the sun and how it influences our entire space environment right down to Earth's upper atmosphere.
So, like, understanding our cosmic landlord and how its mood swings affect our little corner of the universe.
That's a great way to put it, actually, yeah.
Exactly. And our guide for this cosmic exploration is the National Research Council's report, Solar and Space Physics, a science for a technological society.
A hefty title, but full of really crucial stuff.
Right. Think of this as the ultimate cheat sheet for understanding our place in the solar system. Now, you might be thinking, the sun, what's so complicated about that?
Uh-huh. Seems simple enough.
Oh, you sweet summer child of the cosmos. What's fascinating here is just how deeply the sun's activity shapes our technological society.
Mm.
It's not just about sunburns and, powering solar panels. We're talking about a constant interaction that can have some pretty significant consequences down here.
Definitely. So our mission today, if you choose to accept it,
And you're listening, so you kind of have.
right, is to pull out the most fascinating and crucial insights about how the sun's activity influences everything from power grids to GPS.
And what scientists are learning and still trying to figure out
Yeah.
about this incredible relationship.
Yeah, we'll even touch on the surprisingly complex dance happening way up there in Earth's upper atmosphere.
Okay. Should be some aha moments
Mhm.
without needing a PhD in astrophysics, hopefully.
That's the plan. Okay, let's unpack this. The report emphasizes that heliophysics has yielded, well, spectacular insights recently. What kind of advancements are we talking about?
Good question. Where do we even start?
Well, if we look at the past decade or so, the report highlights that advances in heliophysics have given us a much better understanding of the fundamental physical processes at play near Earth.
Okay, like what?
We're talking about the dynamics of plasma, which is essentially a superheated gas where electrons are stripped from atoms.
Right. Makes it electrically conductive.
Exactly.
Yeah.
And highly influenced by magnetic fields. Then there's the behavior of those magnetic fields themselves and how energy and particles from the sun interact with our planet's space environment.
And this isn't just academic theory, right?
Not at all.
Yeah.
What's fascinating here is that this understanding directly informs our ability to, for example, predict harmful space weather events, things that could impact daily life.
Space weather. It always sounds so sci-fi, but this report makes it clear it's a very real thing.
Hmm.
It even mentions a severe solar storm way back in 1859. The Carrington event, wasn't it?
That's the one. Caused auroras as far south as Central America, apparently sparked fires in telegraph offices.
That sounds intense. Imagine your phone suddenly setting your desk on fire.
It does. And the report underscores that a similar event today could have severe effects on our modern infrastructure.
Particularly the power grid.
Yeah, potentially causing widespread outages by damaging transformers. To give you a more concrete idea, a storm of that magnitude could induce ground currents strong enough to melt the copper windings in those high-voltage transformers.
Help them. Wow.
Yeah, leading to blackouts potentially lasting for months across large regions.
Months. That's sobering.
It is. And it also notes that even less extreme solar storms have caused power outages in places like Quebec and South Africa in more recent times.
Okay, so this really highlights the societal and economic value of understanding and maybe forecasting space weather.
Definitely. It's not just about pretty lights in the sky, though those are nice too.
Right, this stuff can actually mess with our technology. The report also talks about the Heliophysics Systems Observatory. What exactly is that? Sounds very official.
Think of the Heliophysics Systems Observatory, or HSO, as a network. It's not a single telescope or satellite,
Okay.
but rather an array of NASA's existing heliophysics flight missions and the NSF's ground-based facilities, all operating simultaneously. They're all working together.
Ah, so coordinated observing.
Precisely. It allows us to move beyond single-point measurements to build a truly global picture of the Sun-Earth system, much like going from a single weather station to a whole network for terrestrial weather forecasting.
Got it. More data points give a better picture.
Exactly. And this richer data set is crucial for tackling increasingly complex and long-term scientific questions that ultimately affect our technology and safety.
And there are new missions coming online too.
Yep, missions currently under development are set to expand this observatory even further, promising new discoveries that will refine our understanding and predictive capabilities.
So it's like having a whole fleet of cosmic detectives all working together to keep an eye on things for us. That makes sense.
That's a good analogy.
Now, the report mentions a few specific missions. Solar Probe Plus, for example, which is now Parker Solar Probe, right?
That's right, Parker Solar Probe.
Sounds like it's getting up close and personal with our star.
Absolutely. Parker Solar Probe is a pioneering mission designed to actually enter the sun's outer atmosphere, the corona.
Whoa, into the corona.
Yeah, to gather crucial information. It's repeatedly sampling the solar coronal particles and fields right there.
What's the goal? What are they hoping to find?
Well, the goal here is to finally understand some fundamental mysteries, such as why the corona is so much hotter than the sun's surface, which is weird when you think about it.
It is strange, yeah. Further away, but hotter.
And also how the solar wind gets accelerated and how those energetic solar particles are formed and transported.
These seem like pretty key questions for understanding space weather origins.
They are absolutely key questions when it comes to understanding the origins of the sun's activity and predicting variations in the space environment that can have tangible impacts back here on Earth.
Wow, directly into the sun's atmosphere. That's some serious deep diving. What about this Explorer program the report talks about? Sounds like the committee are big fans.
They are. The report emphasizes the Explorer program's strength in its ability to respond quickly to new scientific concepts and developments.
So they're more nimble.
Exactly, more agile. It also highlights the program's cost-effectiveness in delivering significant science results and its synergistic relationship with larger, more strategic missions.
And the committee wants more of them.
They do. They actually recommend increased support for the Explorer program, believing that a cadence of one mission every, say, 2 to 3 years would allow for even more significant scientific advances in solar and space physics.
Advances that eventually help us.
Right. They even suggest that with more funding, they could bring back medium-class explorers, which historically have been able to tackle some really high-level science questions.
So these are the smaller missions that can jump on new discoveries quickly. That's pretty cool. The report also has a recommendation about rechartering the National Space Weather Program. Why is that important?
That recommendation really speaks to the need for a more coordinated and comprehensive approach to dealing with space weather.
Getting everyone on the same page.
Pretty much. The survey committee suggests rechartering the National Space Weather Program under the auspices of the National Science and Technology Council, with active participation from key government offices.
Okay, so higher level coordination.
Right. The idea is to build upon current efforts, leverage the new knowledge and capabilities that will come from the research programs recommended in the report.
Like the HSO and Explorer missions.
Exactly. And develop additional tools, both on the ground and in space, specifically tailored for space weather monitoring and prediction.
It sounds like they want to take space weather forecasting to the next level, make it more of a national priority.
That seems to be the goal, yes.
Now, another thing that caught my eye was the mention of the deep solar minimum in 2008, 2009. What was so significant about that?
Ah, yes. That period provided a really unique opportunity for scientists to study the heliosphere, the sun's sphere of influence, under conditions we hadn't seen since the dawn of the space age.
Like unusually quiet.
Extremely quiet.
Yeah.
And thanks to missions like Stereo, we could even study it in a truly global way for the first time. During that minimum, cosmic ray fluxes near Earth reached record highs.
More cosmic rays got through because the sun's shield was weaker.
Sort of, yeah. The sun's activity, its wind and magnetic field, normally pushes back more against galactic cosmic rays when it quieted down.
More got in. Okay.
Right. Also, Earth's upper atmosphere experienced less heating from solar ultraviolet radiation, leading to unusually low drag on satellites.
Oh, interesting. So less atmospheric density up there.
Exactly. And the radiation belts were at historically low levels of intensity. This was all linked to a historically weak solar wind.
So it was like a natural experiment.
Precisely. It taught us a lot about the Sun-Earth connection under extreme, quiet conditions, which helps us build more resilient technologies.
So even the quiet times for the sun can be scientifically valuable. That's good to know. The report also delves into the structure and dynamics of the solar wind itself.
I always just pictured it as a steady breeze of particles.
Mm-hmm. A common picture.
Is it more complicated than that?
Oh, it's much more dynamic than a steady breeze, and understanding that complexity is important for predicting its effects.
Okay.
Over the past decade, we've made significant progress. We now know the solar wind has different origins on the sun. Fast wind from high latitude regions, often coronal holes,
Right?
and slower wind from low latitudes near the sun's equator.
And we can tell them apart. Yeah, what's particularly interesting is that we can now identify and distinguish these different types of solar wind by their ionic composition, their chemical fingerprint almost.
Cool. And what about CMEs, coronal mass ejections?
Right. We also know that CMEs, those massive expulsions of plasma and magnetic field from the sun, interact with these solar wind streams.
Creating more complexity.
Exactly. Leading to complex fluid interactions and also the acceleration of particles to high energies that can impact satellites and astronauts.
And scientists are looking even closer now.
They are. They're even analyzing the fine-scale structure of the solar wind, trying to understand how turbulence dissipates and heats this expanding plasma.
All to better predict its behavior near Earth.
That's the goal. Predict its behavior and potential impact.
So it's like a constantly shifting cosmic river with different currents and bursts of energy all hitting our way. That paints a much more vivid picture.
It does.
And how does all this solar wind activity affect Earth's magnetosphere, our planet's defense shield?
Well, the interaction between the solar wind and Earth's magnetosphere is a central focus of heliophysics. It directly impacts space-based technologies and can even have effects on the ground.
Right, the shield isn't perfect.
No, the magnetosphere, our planet's magnetic shield, is constantly being buffeted and shaped by the solar wind and its embedded magnetic field.
We've learned a lot about how that energy gets in.
We have. We've learned a lot about how energy and momentum are transferred from the solar wind into the magnetosphere, driving various phenomena like geomagnetic storms and substorms.
Which can disrupt communications and navigation systems, GPS, for example.
Precisely. Global imaging and in situ, direct measurements have been crucial in revealing the dynamics of this interaction.
You mentioned magnetic reconnection earlier.
Yes. We now have a much better understanding of magnetic reconnection. It's a fundamental process where magnetic field lines break and then reconnect, releasing enormous amounts of energy.
Like snapping rubber bands.
Kind of like that, yeah. Imagine two sets of stretched rubber bands. The magnetic field lines snapping and then reconnecting in a different configuration. That snap releases a huge amount of energy.
Accelerating particles and causing disturbances.
Exactly. Driving disturbances throughout the magnetosphere, influencing the space environment around our planet. This process plays a key role in how the solar wind influences Earth's space environment.
Magnetic reconnection sounds like sci-fi, but it's real and constantly happening.
Very real.
The report also talks about the surprising role of Earth's upper atmosphere in all of this. I always thought of it as just passive, just sitting there taking hits.
That's a common misconception, and it's exciting how our understanding has evolved. It turns out it plays a much more active role.
Active how?
There's a growing appreciation that Earth's upper atmosphere, including the ionosphere and thermosphere, isn't just a passive layer. It actively interacts with both the magnetosphere above and, crucially, the lower atmosphere below.
The low atmosphere, like our weather.
Yes. It turns out that meteorological processes in the troposphere and stratosphere, our weather layers, can significantly influence the variability in the upper atmosphere
How does that work?
through the generation and propagation of waves. Things like solar radiation absorption, even surface topography, mountains, and weather systems down here can send waves propagating upwards.
And these waves affect the ionosphere.
They do. They affect the structure and dynamics of the ionosphere, which in turn can impact things like GPS signals and radio communications.
So it's a much more interconnected system than we previously realized. Weather down here affecting space, weather effects up there.
Exactly. It shows how even seemingly terrestrial phenomena can have space weather consequences.
That's mind-blowing. And this dynamical neutral atmosphere ionosphere, coupling that the report mentions, what's its goal?
The dynamic mission aims to clarify this complex variability in structure in the near-Earth plasma that's driven by energy from the lower atmosphere.
Trying to untangle those connections?
Right. Providing crucial insights for improving our models and predictions. It involves two identical orbiting observatories that will work together.
Two satellites working in tandem.
Yes, to study how waves from below influence the upper atmosphere and ionosphere. We hope to gain a much better understanding of this crucial coupling region and its role in the overall Sun-Earth system.
Which should lead to more accurate space weather forecasts.
That's the aim.
It sounds like we're constantly discovering new ways that the sun and Earth are linked. A truly dynamic relationship with direct consequences for us.
Absolutely. And the report emphasizes that our understanding of Earth's heliosphere isn't just about our own backyard.
Oh, how so?
The physical processes active here, reconnection, particle acceleration, plasma dynamics, they're thought to be universal.
So, studying our system helps us understand processes happening around other stars and planets.
Exactly. By deepening our understanding of our home in space, we also inform humanity's understanding of some of the most basic workings of the universe and other planetary systems.
Which could have unforeseen benefits down the line. That's a pretty grand perspective.
It is. And as human exploration extends further into space, and as our technological infrastructure becomes increasingly reliant on space-based assets,
Which it absolutely is.
this deeper and more fundamental understanding of these governing processes becomes ever more critical for our future.
Well, this has been a fascinating deep dive into the world of heliophysics. It's definitely given me a whole new appreciation for our seemingly simple sun.
It's anything but simple.
Really? As its profound impact on us.
It's a complex and interconnected system, for sure. And the research highlighted in this report is really pushing the boundaries of our knowledge.
With significant implications for technology and, well, our place in the cosmos. Okay, let's quickly recap the really mind-blowing stuff.
Good idea.
We learned how the sun's magnetic field drives space weather, potentially impacting power grids and GPS. Big deal.
Major potential impacts.
We saw how Earth's upper atmosphere isn't just passive, but actively interacts with both the sun and our lower atmosphere in surprising ways.
That lower atmosphere connection is still pretty wild to think about.
Totally. And we got a glimpse at the cutting-edge research and missions planned, like Parker Solar Probe, the HSO network, dynamic, to better understand and even predict these vital connections.
All aimed at improving our knowledge and protecting our infrastructure.
So, the next time you hear about a satellite glitch or a disruption in communications, remember,
It might not be simple equipment failure.
right, it could be the latest ripple effect from our ever active star, a reminder that we live within this vast, interconnected cosmic system.
Definitely makes you think. What other seemingly terrestrial problems might have roots in this space environment? It's something to ponder.
For sure. And this deep dive, it's really just the beginning. The report we explored is packed with even more detail.
Loads more on specific missions, research goals, the technology being developed.
So, if you're curious to learn more about the future of space weather prediction or the intricacies of Earth's magnetosphere,
You can find resources related to the National Research Council and heliophysics research online pretty easily.
absolutely. What unanswered questions sparked your interest today? It's definitely worth digging deeper.